Welcome to This Explainer. Today, we are tracking down a literal invisible hero, one that's been quietly watching over our rapidly changing planet from space for more than 50 years. We're talking, of course, about the Landsat program. It's a joint initiative between NASA and the US Geological Survey, and honestly, if you want to understand how our Earth is shifting from exploding urban sprawl to the retreat of massive glaciers, this is it. This is the definitive record. So let's jump right in. You see, to truly wrap our heads around global changes, human eyes just don't cut it. We need a kind of supervision. We only actually perceive a tiny fraction of the light reflecting off the Earth. But when we look at the planet through completely different wavelengths, wow, it reveals these entirely hidden landscapes of data. So, how does this actually work? Well, it all comes down to multispectral observation. That's the core technology making this supervision a reality. By capturing data across specific wavelength ranges of the electromagnetic spectrum, think near-infrared or shortwave infrared, these satellites pull out information that is totally invisible to us. It lets scientists measure everything from the health of a forest canopy all the way to the invisible moisture evaporating right off an agricultural field. And that brings us to the hardware itself. First launched way back in 1972, Landsat represents something truly incredible. It is the world's longest continuously acquired collection of space-based, moderate-resolution land remote sensing data. Just think about that for a second. We literally have an unbroken, continuous photographic and spectral record of the Earth's surface spanning decades. Looking all the way from Landsat 1 in '72 right up to Landsat 9 today, this deep historical archive is without a doubt Landsat's biggest advantage. Now, a single Landsat satellite has a revisit time of 16 days. But when you get two operating in tandem, like Landsats 8 and 9, that drops to just 8 days. And because they've been capturing data at a 30-meter resolution for all these years, scientists can run these massive, long-term time series analyses. It's basically the ultimate flipbook of Earth, letting us track urbanization and climate change over a half-century. Over 87 million. That huge number is the amount of scenes downloaded right after the USGS made the entire Landsat archive completely free to the public back in 2008. Before that, this data was commercialized and, frankly, pretty expensive. But this revolutionary open data policy completely removed the barrier to entry. It essentially catalyzed an absolute boom in global Earth observation research. Taking down that paywall has been called one of the world's greatest open data success stories. And it really is. It sparked a literal renaissance in scientific innovation. Suddenly, a researcher anywhere in the world could study the retreat of the Aral Sea or track water quality in Iowa without constantly stressing over their budget. It turned an impressive government project into a truly essential global utility. Okay, let's explore some of Landsat's unique superpowers, starting with its thermal sensors. Current active satellites are equipped with a thermal infrared sensor, or TIRS for short, which captures thermal data at a 100-meter resolution. It essentially detects energy emitted as heat straight from the Earth's surface. And guys, this is a massive deal. It means scientists can measure exact surface temperatures from space, making it uniquely suited for some highly specific environmental monitoring. Now, you'll often hear Landsat compared to Europe's Sentinel-2 satellites, but really, they form the perfect team. Sentinel-2 boasts a super-fast 5-day revisit time, but Landsat brings that unrivaled deep historical context, dating back to the 70s. And crucially, it brings the thermal imaging that Sentinel-2 actually lacks. Combine them, and we get an incredibly comprehensive view of the Earth. Section 2, Landsat in Action, Real-World Global Applications. Let's get right into it. So what do all these high-tech superpowers actually do for us down here on the ground? Why does a 30-meter multispectral pixel actually matter to you and me? Well, first up is forest management. Landsat's medium resolution is perfectly tailored for monitoring global forest dynamics. Because the data is free and incredibly robust, it drives massive operational systems like GLAD alerts. These systems can literally detect illegal logging and new access roads in remote tropical forests on a near-weekly basis. Plus, it's absolutely foundational for estimating above-ground forest biomass and carbon stocks. It's also completely changing the game for water management. By tapping into those thermal bands we just talked about, scientists can calculate what's called evapotranspiration. That's basically figuring out exactly how thirsty crops are by calculating the water they consume and what evaporates right out of the soil. It's a lifesaver for allocating water sustainably in drought-prone areas. Oh, and that same thermal data? It tracks toxic blue-green algae or cyanobacteria by monitoring surface water temperatures in lakes. That helps forecast harmful blooms and protects our drinking water. And the applications definitely do not stop at the shoreline. Surprisingly, Landsat's visible bands can actually penetrate clear coastal waters to estimate the depth of the seafloor. This process is called satellite-derived bathymetry. Agencies like NOAA use it all the time to discover uncharted reefs, track shifting sandbars, and figure out the safest routes for maritime navigation. When doing this kind of coastal mapping, researchers point out just how far the tech has come, specifically noting that Landsat 8 is overwhelmingly better than older models. Why is it so much better? It comes down to this incredible 12-bit radiometric precision and a specific cirrus band that cuts right through atmospheric noise. This high level of measurement fidelity means researchers can spot incredibly subtle differences in surface texture and water quality that would have just looked like static on older instruments. To really see this invisible data at work on a massive scale, think about a glacier. In natural color, it looks pretty static, right? But layer on a Landsat-derived heat map, and suddenly you can track the actual speed of the ice flow. By leveraging that improved sensitivity, scientists are now mapping the speed, movement, and strain rates of almost every large glacier and ice sheet on Earth in near real time. It is absolutely crucial for understanding sea level rise. And grounding all of this in some terrifying reality, Landsat is a literal lifesaver for disaster response. Right after a wildfire, emergency teams use Landsat's shortwave and near-infrared bands to map out the burn scars. By measuring exactly how severely the soil burned, these teams can rapidly predict where devastating post-fire landslides and mud flows are most likely to happen. This isn't just academic. This data directly drives mitigation strategies to save communities from events powerful enough to displace giant boulders, like the one geologists are measuring from the Montecito debris flow. Looking ahead, the mission absolutely continues. Landsat 9 carries some seriously advanced instruments, like the Operational Land Imager 2, or OLI-2. This thing even boasts a hyper-sharp 15-meter panchromatic band right alongside its standard 30-meter resolution, plus that updated thermal infrared sensor. It really sets the program up to lead us into its second half-century of continuous Earth observation. It's ensuring this unbroken record of our home doesn't just survive, but gets sharper and more precise every single year. I want to leave you with this thought. For over 50 years, we've had the ultimate invisible hero watching over us, quietly compiling the most comprehensive biography of our changing planet ever created. The data is free, the tools are sharper than ever, and the archive grows every single day. But ultimately, it's up to us to take this incredible open data and actually use it to protect our home. How will we let this supervision guide our next half century? Thanks so much for joining me on this explainer, and keep looking closer.